Hello and welcome to this Vivaro Quick Take video, introducing you to the Xilinx Zynq7000 Verification IP, now available in Vivaro Design Suite 2017.1. In this presentation, I will provide an introduction to the Zynq7000 Verification IP. I will then discuss the example design, and finally I will finish with a demonstration of how to configure and simulate the example design. The key goal of the Zynq7000 Verification IP is to provide users the ability to verify and debug transactions between the programmable logic and processor subsystem in the virtual simulation environment, which can translate to accelerated design productivity. The Zynq7000 Verification IP models all 9 of the Zynq SoC AXI processing system data interfaces, including on-chip memory and external DDR memory. The user can also control resets, read and write registers, and process interrupt requests using the provided Application Programming Interface, or API. Additional features include being able to set traffic profiles for different AXI master and slave ports, configure latencies for read and write responses, and set arbitration priority on a per slave port basis. It also provides full protocol checking and monitoring capabilities. The Zynq7000 Verification IP replaces the Zynq7000 BFM that was available in previous versions of Vivaro Design Suite, is license-free, and is supported in Vivaro Simulator and major third-party simulators. As the block diagram shows, the user can create stimulus that represents their particular design's behavior and verify against it by accessing the programmable logic through the AXI master and AXI slave ports, and programming the API interfaces to exhibit defined behaviors. The Zynq7000 VIP consists of 2 general-purpose master AXI interfaces, 2 general-purpose slave AXI interfaces, 4 high-performance slave interfaces, and 1 ACP or accelerator coherency slave port. The user accesses these AXI interfaces via API calls through the highlighted user interfaces shown, and is able to program transactions to control reset, read registers, preload the on-chip and sparse memory models, and respond to interrupts from the programmable logic. The Zynq7000 VIP is delivered as an output product of the Processor Configuration Wizard when the Zynq7000 processing system is implemented as part of a block design. Vivaro Design Suite 2017.1 includes an example project and simulation example to enable the user to understand how to use the Zynq7000 VIP. This example design shows how to interface to the Zynq7000 VIP using API commands on AXI Master Port 0 to execute transactions to the GPIO for driving the LEDs and transactions to the BRAM controller for writing and reading to block memory. It uses the ZC702 or ZC706 evaluation board selected by the user at project initialization time, so it is pre-configured. Now I'm going to show you how to access the Zynq7000 example project in Vivaro Design Suite. First, you need to start Vivaro Design Suite 2017.1. When you are at the startup window, select Open Example Project. When the pop-up window appears, select Base Zynq from the template column and select Next. At the next dialog box, enter the project name and press Next. Click through and select the Finish button. This will initialize the project in Vivaro using the Zynq evaluation board as a target. The example design will populate the canvas window. If changes to the processing system are desired, double-click on the Zynq Processing System box. A Recustomize IP dialog box will open, showing a block diagram of the Zynq processing system. If no changes are made, press Cancel on the dialog box. To simulate the example design, select the Sources tab in the upper left corner of the block design window. Click on the drop-down arrow under Simulation Sources, right-click over the Sim1 selection, and select Run Simulation, Run behavioral simulation from the pop-up menu. This will launch the design compilation and simulation in Vivaro Simulator. If desired to use a different simulator, the user will need to go to Tools, Setting, Simulation under Project Setting, and select the alternative simulator. This example simulation does AXI accesses to drive GPIO pins that drive the external LEDs to on, and also does a write and read to and from the BRAM memory on master AXI port 0 of the processing system. By selecting the Run button, the waveform will display the LED bus going from 0 to F. In the Tickle console, you'll also see the specific AXI write that is done to drive the LEDs through the GPIO ports. By looking at the Zynq test bench, you can see the specific commands used to drive the transactions. As you can see by the example code, a write to the GPIO is being performed that results in the LEDs being driven to on. The waveform shown here highlights this transaction. In the next lines of code shown here, a write to BRAM is being done with the data value of dead beef. The code is then executing a readback of the data from the previous written address, and the received data is being compared against the expected value of dead beef. The waveform shown here highlights both the write and read transactions being performed. In this quick take video, we've talked about the Zynq7000 Verification IP, now available in Vivaro Design Suite 2017.1. Please reference the Zynq7000 Verification IP DS940 datasheet for more details on the API usage and examples. Thank you for watching this Vivaro quick take video on Zynq7000 Verification IP.